Hello and welcome to the latest video by Lacey Maths and Stats Consultancy. My name is Sean Lacey, and in this video I'm going to demonstrate how to do a histogram in ggplot in RStudio, but then also how to edit the histogram and to format it based on, I suppose, my own experience of things, tasks that I would often encounter. I'm going to look at kind of 7 different things that I'd often use myself in my own work. The first is one that's quite obvious, is basically setting how many intervals or how many bars or bins are needed in the histogram. The second would be around labeling and scaling the axes. The third is quite a nice one, using this stat bin function in RStudio, in ggplot, where you're going to annotate on the bars with the frequencies or the counts. Including and excluding the cut points is something that's not overly obvious in ggplot, so it's definitely an important thing that I want to cover. Some people like having the bell-shaped curve over their histogram, so I'm just going to show how to use that, and then I'm going to look at if you have a histogram and you want to split it with respect to multiple factors, which is ultimately leading into the kind of the facet grid function, which is something I would use on a regular basis. And then I'll close out the video by just giving an example of how to change the color of the bars if that's something that you'd be interested in your own work. So I'm going to start off first, obviously, by just getting a bit of data. Now, I had in mind that for this video I would look at just kind of a histogram which would be normally distributed. I just said for appearances wise it would just work quite well. So what I'm just looking at doing here is I'm just randomly selecting numbers between 1 to 20, 10 numbers between 1 to 20, 20 numbers between 21 to 40. Then on the line 5 I'm looking at 30 numbers between 41 to 60, 20 numbers between 61 to 80, and then 10 numbers between 81 to 100. So this is basically looking at numbers that obviously will be have this kind of very nice bell-shaped curve appearance to it. So I'm going to look at, I want to obviously select these numbers randomly, but I want them to be reproducible, so I'm using the set seed. So these are going to be the kind of the 5 sets of numbers. I'm putting them all together then on line 8 as an actual vector, and then I'm going to just introduce 3 factors here. This is more just down to demonstrating the facet grid function towards the end of this video. So the first factor is going to have 2 levels, low and high. The second factor is going to have 2 levels, type 1, type 2. And the third factor is going to have 3 levels, level 1, level 2, level 3. Then I'll create it as a data frame, put all that information together as a data frame. And then when it comes to the factors, I'm just ordering the levels. Now, obviously they default to alphabetical order. So the only one I really needed to order was the first factor to be a low and a high, as opposed to be a high and a low as a default. The other 2 factors didn't need to be actually ordered because they were already in the order by default, but I just said for completeness I would do that. So that's just putting together the data frame. I'll just kind of view the data frame here because just to see what it looks like. So you can see this is our data frame here. So we have a column of our measurements, the 90 measurements, a factor 1 which has a low and a high setting, a factor 2 which is a type 1, type 2 setting, and a factor 3 which has the 3 levels to it. So the first thing I'm going to do is I'm just going to generate just the default histogram using the ggplot2 package and obviously the ggplot function. So this is just where using the function ggplot, specifying the data frame, specifying the quantitative measurement which will go along the x-axis, saying that I want it to be a plot as a histogram as opposed to a box plot or a dot plot or anything like that. And then I'm just looking at the team equals the BW team. I think that's quite nice. Obviously there's loads of different types of teams that you could use, but I'll stick to the BW team for this video. So down on the bottom right hand side of my screen you can see then that a histogram is produced. Over on the left hand side in the console you can see a slight warning appears just to saying that we haven't specified how many bars or how many bins. That bins is the wording that you'd use when you're looking at a histogram. How many bins we actually wanted in the histogram. So it's just giving it a warning that it defaults to 30 bins. So obviously my first protocol would really be specifying how many bins I actually want. Now obviously I've tailored the data to kind of have these kind of 5 bars in it, where obviously the number is going to be from 0 to 20, then 21 to 40 and so on like that. If I was looking at this data for the very first time, as in if this was raw data and I didn't have a good idea to what the measurements actually would be, what I would really do is I'd first look at trying to determine, what is the min and max values, or what are the min and max values for the measurement, and then that will give me an idea to how many bars I actually want to include. So here you can see that the min and max values are 3 to 100. So then, from my head I'd be thinking, going up in steps of 20 would make sense. So 0 to 20, 20 to 40, 40 to 60. I'll talk about that crossover of 20 and 40 in a few minutes. But that's how I'd look at doing it. How I'd specify that then is in the GOM histogram, I would say breaks equals a sequence of numbers from 0 to 100 going up in steps of 20. So that's what I'd look at doing in that case here. And if I generate that here, so I've done the range. If I look at that here, this now will produce just a nice box, a nice histogram here. And this is obviously what I wanted. This is how I've tailored the data, that there's going to be 10 measurements in the first bin, 20 measurements, 30 measurements, 20 and 10. So it's obviously generating the way we expected, but obviously, you know, when it's your raw data, you don't necessarily know at the first go what way it will actually look. So this is how the approach that I would often use for it. Then I suppose so that's my first protocol. My second protocol, which is a kind of a default to how I would look at generating most of my graphs, is looking at the labeling of the axes and the scaling of the axes. Now over here, if you look at the graph here, that there's nothing so wrong, so to speak, with the labeling here. My only thing is with the y-axis here, it says count. Nothing wrong with the word count. I would just think that you'd use an uppercase C if you're going to use the labeling of the axes. For the x-axis here, the horizontal axis, it's a measure. That's what I've called it. If the measurement, I'd imagine, will have a unit, so I'd always kind of state the unit in brackets. Now here I'm just going to call it a unit, but for your own data, I think it's always good practice to kind of, when you have a quantitative measurement, that you state what the unit is in brackets. It just makes the interpretation a bit easier for people kind of going forward. So what I'm looking at doing here is I'm going to open up the graph in a separate windows, which is something that I'd often do. On line 28 is where I'm taking the previous graph, so I've called it P1, and then I'm labeling the x and y axes. On line 29, I'm just scaling and saying to scale the axes. So the x-axis is going from 0 to 100, the y-axis from 0 to 30. On line 30, then I'm looking at saying, well, the x-axis is going from 0 to 100 and it's going up in steps of 20. The y-axis is going from 0 to 30 and it's going up in steps of 5. Then I have my line 31, then it's just increasing the font size. I found that when I'd export these graphs to Word, or I might be looking at saving it as a PDF or a PNG and then using some LaTeX or something like that, I often found that increasing the font size is something that would be needed just to make the graph look quite nice in the report. And for me, what seems to work nice is having a size equals 15. So that's what I'm just going to do here. I'll generate this graph, and to me this looks quite good. I'll talk to you later on towards the end of the video about changing the colors of the bars, but just as a first take of a histogram, I think that this is quite nice. Those of you that might be new to using RStudio or using ggplot or even using the Windows function here, you can come up here to the file, you can go down to Control-C, you can do your Control-C to save it like we traditionally would do things, or you could save it in these various file formats as well. So I think that that's quite nice. One thing that I suppose that sometimes people might necessarily be overly happy with is when you look at these graphs, is just the way you can see, look, that we're scaling it from 0 upwards on the vertical and the horizontal axes, but yet there's a gap here. So sometimes people don't like to see this gap. They like the graph to be flush with the axes. So I'm just going to show you how to do that in one case. I'll do it for the x-axis just to see how to add in that, because it is, sometimes people would like to have the graph to be flush with the axes. So what you'd say here is you'd add in expand equals C 0, 0 like this. I'll leave the other axes alone, and this is how I'll generate it here, and I'll look like this, and you can now see, look, it's now flush with the axes. So if I just scroll back to the previous one here, this was the one before I edited. You can just see here, look, that there's a gap here on the left, while now here if I do the expand 0, 0 C equals 0, expand equals C 0, 0, you can see then that now it's flush with the axes, and you can do that then for the y-axis as well. Sometimes people like to do that. I to and fro. Sometimes I do it and sometimes I don't. It all really depends on how the graph is actually looking. Then the next thing I just want to show, and this is a very nice function I think for ggplot, is where you can annotate on your bars. Now I'm actually just going to get rid of, or I'm going to remove the expand there just for this, because I think it's actually nicer nearly having the gap. I actually like it like this, so I'm just going to remove that expand because I'm using the plot. I've called it P2 here, and I'm using this plot now in this next part and annotating. And so what I'm saying here is I basically want the numbers 10, 20, 30, 20, 10 to appear in the graph. That's what I'm looking at doing here. So using the stat bin function, I'm saying that the intervals are going from 0 to 100 up in steps of 20. That's obviously important. Stating that it's a text. What text I want to appear is going to be the count. I want the text as in, which is basically your frequency. I want the text color to be white. And then this is just adjusting the position of the text. So this is something that you can play around with. This is just the vertical adjustment of the text, and then the size of the text. That's what you look at here. And if I generate this quite nicely, I think it works out quite nice. It just gives the frequencies for each of the bars, which I feel is quite nice. But then this then kind of would lead into this idea of the cut points, which is what I'm going to move on to next here. Is if you're looking at interpreting this first bar as an example, you could say, look, that there's 10 measurements between 0 to 20. If you look at interpreting the second bar, you'd say, look, that there's 20 measurements between 20 to 40. So the obvious question I would think then is, well, where is measurement 20? Does measurement 20 fall into the first bar, or does it go into the second bar? Okay, and then that will be the same for all the other cut points. The measurement 40, is it in the second bar, the third bar, and so on like that, okay? And it's not overly obvious, and packages do vary with how they actually do this. So just to kind of highlight, essentially the default for ggplot is that the endpoint is included in the bar. So this bar here will be 20 measurements are in the interval of 0 to 20, including 10 measurements are in the interval of 0 to 20, including 20. So the cut point is included in the bar. That's the default. And just to kind of show that that is the case here, what I'm looking at doing is I'm creating another variable. I'm calling it right for being that the cut point is on the right. And it's just using an if-else function, where if a measurement is less or equal to 20, coded as 1. If a measurement is less or equal to 40, coded as 2. So this is where I'm kind of grouping the data where the endpoint is going to be included in the bar. And then I'm just going to run off a frequency table. Now, there's going to be nothing new with this. This is what we'd expect. This is where we have the 10, 20, 30, 20, 10 as the frequency if you look down the bottom left-hand side of my console. Now, just to highlight that the cut points definitely are included in the bar, I create another variable here. This is where I'm not including the endpoints now. So I'm kind of saying, look, let the measurement is coded as 1 if it's less than 20. So that means everything up to 20 coded as 2 for less than 40. So this is where I'm not including the endpoint. And if I do the frequency on that, in this case, then you can see that the frequency is slightly different, okay? So this is just kind of highlighting that when you generate a histogram in ggplot, the endpoints for the bars are included in the actual bar, okay? If you didn't want it to be, because it's actually quite traditional for a lot of packages that the endpoint is not included, how you'd specify that is when you're generating your histogram, in your GOM histogram, you would say closed equals left. So the default is closed equals right. That's what we actually have over here on the right-hand side of the screen. If you wanted to change it, you'd say closed equals left. Okay? And what I'm just doing here for P4, this is the graph, I'm generating the histogram from scratch, scaling the axes all the same, and I'm just going to annotate it on it again here. That's what I'm doing here. But when I'm annotating it using the stat bin function, I need to now add in that, look, this closed equals left as well. I need to kind of specify that. And this works out quite nice. There's nothing majorly groundbreaking with it, but it's just to know that that's actually how you handle this in ggplot. So if you want that your endpoint is not included in the bar, then you need to specify closed equals left. Okay, and obviously if you want your endpoint to be included in the bar, you don't need to state anything, or if you wanted to, you can be very transparent and you can say closed equals right. And you can just see by doing this, it's just to be aware of it, and the annotations then can be updated as well, which is quite nice. Okay. The next thing I want to show here is sometimes I don't often do it myself, but sometimes people like to fit the bell-shaped curve to the histogram to kind of have it overlaid over the histogram. If you use the GOM density function, what it will do is it will generate kind of the probability density function. So it will do it as your y-axis, your vertical axis will be scaled basically as a probability. Often what I would, if I was to do it, I would like it to be more looking at the actual raw data, so that actually that the curve that's going to be fitted will align with the frequencies as opposed to the probabilities. So a way of doing that is using the stat function. Okay, so I'm taking P4, which is this nice graph over on the right hand side. I'm using the stat function here, and for the stat function, then I use this the fun equals function measure. So where I get all this information from is there's a nice kind of chat on Stack Overflow. If you kind of put in ggplot2 histogram with normal curve, you'll see all the variations to how to do this. And this is the one that I like the most. This is where I'm fitting a bell-shaped curve over the data. I have to specify if I want it to be scaled based on the frequency as opposed to the probability. I have to specify what is the length of the measurements, essentially that there's 90 measurements, and what is the bin width, so that there's 20 obviously is the width of the bin. I need to specify that, and if I do that, then here like this, you can then see that I get this bell-shaped curve. Now I'm not going to go off formatting this too much. but you might, sometimes this bell-shaped curve might go through your text, so you might need to adjust your text here. But look, I think for this, it works out nicely enough. It's fitting the curve quite nicely. You can see it's a dark red curve here. So again, I suppose it's the minority of the time that I do it, but I do come across researchers, or I suppose people in general, that like to fit the bell-shaped curve, and I'm just showing you a bit of script that would actually do that, okay? Here, so one thing that you'd have to add on to this and to be very much aware of is when you want to scale it based on your frequencies as opposed to the probabilities, is you need to say what your sample size is essentially, and what the bin width is. So the sample size obviously is the length of the measurement that we have, which is obviously going to be 90. And then in this case here, 20 was the bin width, is what I've decided to go with for this video. Okay. The last kind of bit, I suppose, the main cut that will take just a small bit of time is if you wanted to generate a histogram for a measurement, but you want to split it with respect to a factor. Now, so for the purpose of this, I'm just going to look at factor 1. So this is where there was the low and the high settings, okay, for factor 1. You could, I don't do this off, I said I'd start off with this one, but this is not really how I would do it myself. But you could just look at it as very similar to maybe how you would produce a dot plot or a box plot across various factors in ggplot. Is you could just say, look, you state your measurement, then you could say fill equals factor 1. That's all I've done here. I haven't changed anything. So I'm creating a new plot. I'm calling it P5. But all I've added in is fill equals factor 1. The GOM histogram is here. I'm leaving it as close equals left, and then I'm not scaling the axes or anything here. I'm just labeling the axes, and this is the graph that we get back. Okay. Now, so it's okay. I'm not a massive fan of it. Okay, I'm personally not a massive fan. You could do the stat bin on this, and it will work nicely as well. I'm just trying to keep this quite straightforward. Essentially, what's happening here is it's obviously stacking the histograms on top of each other. You could, to highlight that here in your GOM histogram, you could say position equals stack. This is what you have. This is what it defaults to here. So this is what you have. The other option is you could say position equals dodge, like this, like that. That's another option. Some people might like that. The other one is you could overlay them, and now you need to kind of change the colors a small bit to make some a bit lighter so you could see it. But you could overlay it like this as well. Again, I'm not scaling any of these axes, but these are various options that you could use if you're looking at, and obviously this can be applied to where if you have more than 2 levels to a factor, but for the purpose of this video, I'm just looking at a factor with 2 levels. I don't often use this for the histogram. I do use this script very a lot for box plots and dot plots and so on like that, but not very much for histograms. I think for a histogram, the function that I'd often use would be the facet grid function. I find that that's quite a good one to use. And again, just before I move on to the facet grid, you obviously could, for this, you could add in the stat bin, like we've done up here for the previous one. You could add in the stat bin, and it will overlay it and put in the numbers. Okay, they're just, I suppose, not as nice. I'm not a massive fan of it. And I said, look, I'll just try to keep them as clear as possible for this video. But obviously, all the tweaks that I showed up above, they can be added on here. What I'm more interested in, I suppose, again, what I suppose I try to share in these videos is what I'd use myself and my own reports that I would be generating for various clients is, in this case here, is going to be the facet grid. Okay, so I'm going to first just looking at the facet, basically looking at the measurement, which is, I'm going to take the P4 graph again. So just to refresh your memory, P4 is this graph here. So I'm going to take this graph and I'm going to split it with respect to factor 1. Okay, so if I do that like this, here you're going to get this. Now I won't worry about scaling the axes, but obviously this is something that you would look at doing. You would scale the axes. Obviously we don't need all this white space up here, but I'm just for this video here, I'm just going to keep it very I'm not going to do much more formatting here. I just want to kind of show you how to generate these graphs. I do very much like using the facet grid because what it does very nicely is it makes sure that the axes are scaled the exact same way, which is really, really important for comparison purposes. Okay, so that's one way. What you're doing here is you're producing your 2 histograms and they're side by side. There's loads of little tweaks you can do with this. Then is you could look at stacking your histograms, and it very much depends on what your histograms are, what you're measuring to maybe what makes sense. But if you wanted to stack them, you do this tilde dot at the other side of factor 1, and what that does then is it stacks it, which is quite nice how it does that, I would feel. There's other options then is if you wanted to look at putting in 2 factors together. Okay, so what you could do here, I'll just copy this down here. So there's loads of things you can play around with this but if you wanted to, I'll put this tilde at the start. I don't need the dot in front of it here now this time, because I'm going to put in another factor like this, factor 2. I'll keep it as factor 2 at the moment. Facet grade, I think that's okay. And what this will do is, I'll just zoom in on this here. It'll now look at the measurement split with respect to your two factors. So factor 1 was the low and the high setting. Factor 2 had type 1, type 2. And obviously, you know, there's no context to this. This data is all just randomly selected and stuff like that. When it's your own measurement, there obviously will be context, and these things will kind of make more sense. What's very nice with using this, you can see that the stat bit function is used here across the board, which is very nice that it actually does that by default. And I feel that it positions the numbers really, really nicely as well. So I think that's quite nice how it does that. There's loads of little editing bits that you can do this here. I put this tilde at the start. I'll just do another way. I'm just going to do this 2 more times just to kind of show you various options, and then I'm going to finish off this video here. I could put the tilde in the middle here, and what that does quite nicely then is it kind of sets up the data kind of in the box format. So it puts one factor as the kind of the rows and the other then as the columns, which is quite nice how it does this. Obviously, I'm not spending any time commenting on it. This is just looking at the various ways that you can generate histograms in RStudio when you have a measurement with respect to factors. And I think, again, I feel that this is much nicer than using the fill function up above. If you want, now it gets a bit messier when you're throwing in a third factor, but if you wanted to, I'll just kind of show you here. If you wanted to stick in a third factor, I'll put in plus factor 3 here like this, factor 3 like that. It will produce this kind of graph here. It's just taking a second. A bit messier now, there's no doubt about it. It is a bit messier, but it does it. I mean, it does it quite well. You could obviously, you can do the various kind of, you can see here that they're all kind of set up in parallel to each other here. So we have the first factor, which is the low and high setting, the second factor, which is type 1, type 2, the third factor, which is level 1, level 2, level 3. But obviously that's quite very kind of squash looking. You can vary this a small bit by where you position that tilde. So I'll just do once here. I'll take out the tilde here at the start, and what I'll do is I'll put it in the middle here like this, and I'll generate like that. And this is where you get back. So you can kind of be playing around with now. It's definitely when you step it up to 3 factors, it does get more complicated with the graph. I don't know would I really use histograms for this. Some people will like to use them, and that's fine. Probably if I have a factor, a measurement with multiple factors, I'd more likely go down the route of error bar graphs. I think that they could be a bit cleaner. But look, at the same time, people have different purposes for doing histograms. And look, this is just one nice way of doing it. And I think, again, I do feel if you're splitting a measurement with respect to multiple factors and you want to produce histograms, I do feel the facet grid is the nicer way to do it. The last thing I'm going to look at here is just the colors. Okay, so I'm going to, I suppose what I'm going to do is I'm just going to actually show you, look, how the histogram was generated for the thumbnail. So the thumbnail was put together by my daughter Ava, and I'm just going to show you the script that she would have used to actually generate that. So so what I mean, look, there's various ways that we could do this, and that always in RStudio, whenever you're kind of looking to do something, there's more than one way of doing it, and this is just one way I looked at setting the colors to the histogram, which is based on that kind of the thumbnail that we have for this video here. So I'm just, obviously there was 5 bars, so what Ava decided to do is she liked the idea of the symmetry, so she wanted the first bar color to be the same as the last bar color, the second to be the same as the fourth, and then the middle one to be different, which is fine. So she specified her 5 colors, or sorry, the 3 colors, whichever way you want to look at it. For the thumbnail is actually what I'll just do here before I talk about the thumbnail is I'll just generate that here without doing any theme yet or anything like that. I'm just making sure, yeah, that should be fine. So this is what we get back. So I think that's quite nice. Obviously then for the thumbnail, I didn't and we didn't want any labels to the axes. We didn't want any scaling or anything like that. So just to kind of show you maybe, and this is just to finish off maybe on a light note, that this is how you'd remove the labels of your axes. If you wanted to remove them, you basically say your Y label and your X label are blank. If you wanted to remove your axes completely, you'd say your X and Y axes are null. And then if you wanted to get rid of the theme, as in that grey background, you would say then that your theme is void. And this is what Ava would have done for me here for this video. And this was the graph that we got back, which I think was quite a nice colourful thumbnail histogram that we used in the thumbnail. And thanks very much to my daughter Ava for doing that. And look, that's basically it. I suppose for this video, again, it's very much based on I suppose ways that I would find that I'm editing graphs, creating a histogram, and then maybe editing it to various needs. And I suppose that's the main motivation for doing this video. And that's it. Like always, if you like the video, please do a thumbs up below. You can share it, subscribe to the channel, and you'll get the updates when the next videos will appear. And if you had ideas for a few future videos, or ideas that you might maybe add-ons even to this kind of histogram idea, feel free to put it below in the comment, or you can reach out to me on my various handles here. But for the moment, thanks very much for your time. All the best. Keep well.